Hello and welcome to 7.3, which concerns using the central limit theorem. So if you've seen 7.1 and 7.2, 7.1 had to do with the central limit theorem for means, and 7.2 had to deal with the central limit theorem for sums. So we need to understand when to use the central limit theorem. Okay, so if you're being asked to find the probability of the mean, or the average or the sample mean, we need to use the central limit theorem for the mean. If you're being asked to use to find the probability of a sum or total, we need to use the central limit theorem for sums. And this also applies to percentiles. Okay, so if we're being asked to find the probability of an individual value, we do not use the central limit theorem. We use the distribution given for the random variable. All right, so let's do a super fun example. A study involving stress is conducted among the students on a college campus. The stress scores follow a uniform distribution. So, hint, hint, here it is, uniform distribution, with the lowest stress score equal to 1 and the highest equal to 5. Using a sample of 75 students, find the probability that the mean stress score for the 75 students is less than 2. So here's all our key stuff. So we know this is a uniform distribution, right? So the original distribution is a uniform one, where what's the lowest value is 1, and the highest value will be 5, okay? So it's this way. So this is A, this is B, and this is N, right? We have 75 students. So this is basically what we're saying. A is 1 and B is 5. It's given to us that the distribution is uniform. And if you recall, uniform distribution has a particular formula for the mean and its standard deviation, right? So for uniform distribution, the mean is just the average. You take the endpoints and you average them, so you add them and divide by 2. So 1 plus 5 is 6 today, 6 divided by 2 is 3. So the mean for the original distribution is 3, and the standard deviation is the square root of the fraction b minus a squared all over 12. So that's just, remember this is a, and this is always b. Okay, so it's 5 minus 1 squared over 12, which is 4 squared over 12, which is 16 divided by 12, and then you take the square root of that, and that is 1.15. So now we have the original mean and the original standard deviation. So previously, they would give us these values. So this problem didn't give them to us, but they did tell us that the distribution was uniform. And they did give us the lowest and the highest score. And n. So with all that, that's enough to find the mean, and that's enough to find the standard deviation. Okay, so let's continue the problem. So now we're going to use, it wants to know, the problem asks for mean stress score. Sorry, that's an underline. So X, the sample means are normally distributed, where the mean for the sample is the same as the mean as the original. And the standard deviation for the sample means is the original standard deviation divided by the square root of n. So that's this right here. So we need to use that. So that means, so this is from before, and we need to find, so our probability will be using the normal CDF function, right, where you have lower value. In this case, the upper value is 2 because you're looking for probability less than 2. Okay. And then the mean is 3, same as the original, and then the standard deviation will be the original standard deviation, which is right here, 1.15, and that's divided by square root of n, which is 75. So this is what we're looking for. So let's go ahead. The graph will be like this, okay? Here how you do it. You would hit second distribution, go to normal CDF, hit enter. Your lower bound is now 1. Your upper bound is now 2 because we're finding everything up to 2. Our mean is 3. And then our standard deviation for the means is going to be 1.15 divided by square root of 75, okay? And then you go down to paste and hit enter. Enter again. And you see here that it's pretty much 0. That's so tiny that it's basically just 0. Okay, so now what if we wanted to find the 90th percentile? Same situation, but now we want to find the 90th percentile. Now, do you remember what function we use for that? If you said inverse norm, congratulations, you're correct, right? Remember inverse norm? It says we want to find the area here. So we put the area, which is 90%. The mean is 3. Because we're talking about the 90th percentile for the mean stress score, the standard deviation that we enter here, according to central limit theorem, is 1.15 over square root of 75. So we plug all that in. So let's go ahead and do that. So we do second, vars, distribution, down to inverse norm, hit enter. Your area is 90 because you're finding 90th percentile. Your mean is 3. And your standard deviation, because we're finding the mean stress score by CLT, is 1.15 over square root of n, which is square root of 75. Right, and that's the left tail, and then you hit paste and hit enter, and you get approximately 3.2. So what is 3.2? That's the value k such that the area to the left of k on the graph of the sampling distribution is going to be 90% of the total, and that's what that is. Okay, so what if we wanted to find the probability, so same situation, but now it's the probability that the total of the 75 stress scores is less than 200. So basically we're finding, we need to use the central limit theorem for sums because they're asking for the total, okay? We're finding the probability that the total 75 stress scores is less than 200. So the mean, according to CLT, is going to be n times the original. So 75 times the original mean, which is 3. So 225 is your new mean, your mean of the sums. Okay, the standard deviation of the sum is going to be square root of n times the original standard deviation, so that's 9.96. And then we go ahead and we do normal CDF because we're trying to find the probability that the total, so the total of the stress scores of 75 stress scores is less than 200. So when you want to find this, your lower bound is going to be 10 to the 99 power, or negative 1 to the 99. It's going to be negative because you're going to the left, and your upper bound will be 200, okay? And you have 75 times 3 is your mean, and square root of 75 times 1.15 is your standard deviation because we're talking about sums, and we're putting this because of the CLT for sums, okay? And then the probability that you would get that less than 200 is 0.006 or 0.6%. All right, so same situation, except now we want the 90th percentile for the total stress score. So we're finding the 90th percentile, but now we're using CLT for sums. Okay, so we're basically doing inverse norm, 90th percentile, right? You're finding, you're using the CLT for sum, 75 times 3 is your new mean, and square root of 75 times 1.15 is your standard deviation for the sums, okay? So basically this is what we're finding. We're finding K such that P of sigma X less than K is equal to 90%, so right here, okay? So it would be 237.8. That's our 90th percentile. Okay, so yes, another example. Yes, someone is sexually assaulted every 2 minutes in the United States on average, according to a number of studies. Suppose the standard deviation is 0.5 minutes and the sample size is 100. So right here, they already give you everything. They give you the mean, right? Which is what? It's every 2 minutes, so 2. And then they give you the standard deviation. The standard deviation is 0.5 minutes, right? So 0.5. And then the sample size, N, is 100, okay? So these are all things like as you're reading a problem, you need to be making sure that you're aware of what it's giving you. So sample size, standard deviation right here, and then 2 minutes on average. So that gives you the mean. So let's find the median, first quartile, and the third quartile, okay? So in order to do this, you need to remember that the median is the same as the mean, so it's 2. And sigma of x is going to be, because you're finding the sample mean time, we're going to use CLT for the sample mean. So it's the original standard deviation divided by square root of n. Square root of n. So square root of 100 is just 10. So your new standard deviation is going to be 0.05, and your mean is going to be the same too. This actually should be a little x bar. So maybe you can, okay. All right, so 50th percentile is the same as the mean, is same as the median, which is the mean 2, okay? And then 25th percentile, we just use our famous key inverse norm, where we put 0.25. Our mean for sample mean is 2, and the standard deviation of the sample means is 0.05. Okay, so then you would get 1.97, and then finally your 75th percentile or third quartile. So this is median or Q2, this is Q1, and this is Q3. Third quartile, 75%. You use inverse norm, here's 75. The area, probability area, 0.75, mean of 2, and standard deviation for the sample mean is 0.05. So you have these 3 values, okay? What if we wanted to define the median, first quartile, third quartile for the sum of sample times? So we would need to have that the mean of the sums is going to be n times the old mean, so 100 times 2, which is 200, and the standard deviation of the sums, right, is going to be square root of n times the original, so square root of 100 is 10 times 0.5, and that's just 5. So your 50th percentile is just going to be the same as the mean. Your 25th percentile is going to be inverse norm, where the area is 0.25, comma, the mean, and then comma, the standard deviation of the sums, okay? And that's 196.63. And then same thing for 75th, except that instead of 0.25, you put 0.75, okay? So that is these 2 values. And if you wanted to have, let's see, what else? Okay, we're going to get to, let's see here. I think oh yeah. So here, so then we found out Q1, Q2, and Q3 for this last example. So then for part C, it says, find the probability that an assault occurs on the average, so sample mean, between 1.75 and 1.85 minutes, okay? So the original is mean is 2, standard deviation is 0.5, n is 100, so we're going to use CLT for means, where the mean of the samples distribution is 2, same as the original, and the standard deviation for the sample means is equal to the original standard deviation divided by square root of the sample size, so that's 0.05 again. We did this calculation previously, and you plug it into a normal CDF where your lower value is 1.75, your upper value is 1.85, your mean is 2, and your sigma is 0.05. Okay, so you put this in and you get 0.0013, so your probability is 0.13%. Okay, finally, it says find the value that is 2 standard deviations above the sample mean. So you could use, from the z-score formula, you can manipulate it to where x bar is equal to z times the standard deviation of the sample means. This should have a bar right here, and plus the mean of the sample, right? So we have all this from previous. We have everything because they gave us 2 standard deviations. So when they say that, find the value that's 2 standard deviations above, that means that z is equal to positive 2, okay? So we have here the mean is 2, standard deviation for The sample mean is 0.05. So plugging this into here, this formula, x equals 2 times 0.05 plus the mean, which is 2. So z and the mean are the same. So this is 2.1. That's the value that is 2 standard deviations above the sample mean. Okay, and then lastly, it says find the IQR for the sum of sample times. Well, that's great because remember IQR is just the difference between Q3 and Q1, or 75th percentile minus 25th percentile. So there it is. So we just get this from part, I think it was B or C or something. We get 203.37 minus 196.63, which is the 75th percentile, aka Q3, right? Q3 minus the 25th percentile, in other words, Q1, okay? And that's it. And your answer is 6.74. This is the Q1. Okay, so that's all I have for 7.3. Good luck, and I will see you in the next video.